We're going to do some more factoring. So up until now, when there's been a number in the front of the x squared, so that's our a value if you're talking about standard form of ax squared plus bx plus c. So up until now, we've only had an a value of 1. But if we did have one more than 1, a different number in front, it was a GCF. Well, if you'll notice on this one, it's not a GCF. 2 does not go into 11. Therefore, I can't factor out a GCF. So this one is just factoring. It's going to factor like this. And I just now got disturbed by the fact that this says 9.3. That should be 2. So the way to get 2x squared is 2x times x. So one of these has to be a 2 and one of them a 1 because 2 times 1 is 2. They're both plus signs, so it must be a plus sign. But the problem is I have to find the two factors of 12 that when you put them in here and multiply, your middle terms will add to 11. So it's no longer that these two numbers add to 11 because one of them's getting multiplied by 2. So fortunately, someone smarter than I am came up with a little foolproof method that works every time, where you can still use your x, but instead of putting the 12 right here, you have to multiply the 12 times the 2 or it won't work. So the very first thing we're going to do is multiply the first times the last. 2 times 12 is 24. So I now want the factors of 24 that add to 11. Well, if you might see it quickly, you might not, but it's 3 and 8. So 3 times 8 equals 24. 3 plus 8 equals 11. But that's not our answer. That's not what goes here. So let me just get rid of that for a minute. Let's pretend it is our answer. Let's write it like it were our answer. X plus 3, x plus 8. Now that does multiply to 24 and add to 11, but we don't want 24, right? We want 12, and we want 2 in front. So remember how we started off by multiplying this? Well, now we need to get rid of it. We need to divide to get it back out of there. So I put the 2 under both numbers. At this point, there's one very important step that people often forget. This will not work if you don't reduce. You must reduce if you can. 3 over 2 doesn't reduce, but 8 over 2 does. 8 over 2 reduces to 4. Once you have reduced, if it can, then we do what's called bottoms up. I call this method bottoms up because the bottom goes up to the front. This is our answer. If you checked it, 2x times x is 2x squared. 3 times 4 is 12. If you checked your middle terms, 3x, 8x, that does add to 11. I see here that I've written equals 0, but I'm not quite ready to do that. We solved yesterday with 0. I think we should practice this first. So let's practice it on this one. First of all, is there a GCF? We always check for a GCF first. And no, there is not. 3 can't go into these other two numbers. So our first step is to do 3 times negative 8. That gives us a negative 24. Then the negative 10 is what I want to add to. So I want the numbers that multiply to negative 24 but add to negative 10. Remember that to multiply to a negative, you have to have one positive, one negative. So it looks like I'm going to have a negative 2 and a positive 12. That multiplies to negative 24, but it adds. No, it doesn't, Miss Jones. Did you see how I swapped those? Remember that to get the negative, the bigger one has to be negative. So now let's write it as if that's the answer. We know it's not, but we're going to write it as if it is. Remember that I multiplied the 3 to begin with, so now I have to take it back out. Divide by it. At this point, I'm going to check for reducing. If it reduces, I'm going to reduce it. And then if it doesn't, I go to bottoms up. This does not reduce, so I do bottoms up. The 3 moves up to the front. This one, however, reduces all the way to a whole number. It won't always reduce to a whole number. Sometimes it's a fraction, and then you do bottoms up. This one reduces to 4. Now I'm done. I could do a quick check. 3x times x is 3x squared. 2 times negative 4 is negative 8. And then if I checked what I call the smiles, 2x and negative 12, does that add to negative 10? Yes. Let's look at another one. Is 3 the GCF? No, because it doesn't go into 7 and negative 40. So the first thing we do is we multiply our first times our last. So 3 times negative 40 is negative 120. So I want the 2 factors of 120 that add to 7. I don't have my answers written here, so you're going to have to give me a second. Remember, this is a good time to remind you. Remember that if you're bad at your factors, you go to y equals and you put negative 120 divided by x. Then go to the table, and your whole numbers are going to be your choices. And I'm looking for 2 of them that add to 7. And here it is. I've got 8 and 15. Because the 7's positive, the bigger one needs to be positive. So if I had 15 and negative 8, that would add to 7, and it multiplies to negative 120. So let's pretend that's our answer, even though we know it's not. And let's divide the 3 back out because we have to undo it. And 8 over 3 does not reduce, so bottoms up. And then this does reduce. This is a coincidence that these are all reducing to whole numbers. That doesn't always happen. Let's go back to the original. Let's set this one equal to 0 and see what happens. So if 3x minus 8 is 0, one of these has to be 0. Remember, I'm going to set each factor to 0. Either 3x minus 8 is 0 or x plus 5 is 0 or both. This one's easy because I minus the 5 and it flips and it becomes negative 5. This one, however, if we added the 8, 3x equals 8. I don't want 3x. I'm running out of room. I want x, 8/3. So my zeros, my roots, are negative 5 and positive 8/3. Now, wait a minute. Look up here. If I had taken the opposite of 8/3, do you see how right here ends up being our factor? 15 divided by 3 is 5, and I do the opposite. So just a little shortcut if you notice it. If that confuses you, go ahead and solve it. So one more. Is there a GCF? No, because 7 is the only factor of 7, and it will not go into those 2. I start by multiplying first times the last. I get 21. If I'm going to multiply to a positive, both sides have to be the same. But because the middle one's negative, they have to both be negative. So what are the factors of 21 that add to negative 22? Well, it's going to be negative 1 and negative 21. So let's pretend those are our answers. Our factors, x minus 1, x minus 21. Divide by the 7. Because I've multiplied by it, I've got to get it back out. 7x minus 1, because that doesn't reduce. This one does, x minus 3. Now this would be the factors. If I told you to factor that, here are the factors. if I told you to find the roots, set it equal to 0 and solve, I know I can do the opposite of -3 and get +3. I can solve this, or I can look right up here and do the opposite of that. So I have 1/7 and +3.